Alright, Algebra students, we're ready to finish up Chapter 8 with our last set of notes. So let's review. This would be factoring a difference of squares. So it's going to be x plus 11 and x minus 11, a difference of squares. Right here we can't factor because of the negative, so factor out a negative 1. And that'll make 36x squared minus 1. Now we have a difference of squares. So it's 6x plus 1 and 6x minus 1. A square with sides from length b is removed from a square with sides of length 8. So here's an 8 by 8 squared, and we're going to remove this square that's b by b. Write an expression to compare the area of the remaining figure to that of the original. So our original is an 8 by 8, which is an area of 64. And we're going to remove a b by b, which is a b squared. So we're going to have 64 minus b squared. That would be the comparison. So it's a difference of squares. Literally. Okay, review by factoring. We're solving, so that means we're going to have minus 49 equals 0, and both of those are squares, so this is again a difference of squares. See how quickly you can work it through when you realize it's a difference and that they're perfect squares. So we need to solve both of those for 0. So 2c plus 7 equals 0. So 2c equals negative 7. C is negative 7 over 2. And 2c minus 7 equals 0. So c equals positive 7 over 2. So the best way to write this answer, I'm going to write it to the left here, is positive or negative 7 over 2. When it's a difference of squares, we're going to have the same outcome. One's going to be positive, one's going to be negative. So again, the more you practice, the quicker you'll be able to realize that you already know the answer, especially once you solve one of them. I'm going to leave number 2 for you to check on your own. We'll check that in class. Okay, in section 8 and 9, quadratic equations with perfect squares is our lesson today. So a perfect square trinomial means it's going to have 3 terms, and they're both, the first and the last term are going to be perfect squares. Now, what is a perfect square? A perfect square is a number made by squaring a whole number. Okay. It'll be easier to see once we get into working the problems. Our first key concept box has A's and B's. So a squared plus 2ab plus b squared. We know when our second sign is positive that we have the same sign, either both positive or both negative. It's a perfect square if when you factor it out, you have a plus b times a plus b. You can rewrite that as a plus b squared. So really, we're not doing anything new. We're actually going to be looking for shortcuts. So the whole idea is for this to be a shortcut, or for you to realize when you've worked the problem, for you to realize and to write the answer as a perfect square. So we have a question here. Is this trinomial a perfect square trinomial? If so, factor it. Well, this would be our A term, and this is our C term, and they're both perfect squares. See, 5 squared is 25, x squared is x squared, 3 squared is 9. So if we factor it the old-fashioned way, we would multiply 25 times 9, find the product, we'd do product and sum. But instead, let's take the square root of 25x squared and the square root of 9, and we know here that they're going to be the same sign, both negative, and let's check and see if that is, if I do FOIL, do I get 25x squared minus 30x? So when I check it, I get 25x squared. I knew that because I took the square root. Here's the main thing that you need to check, is right here in the middle. Negative 15x, And then I know that should give me positive 9 because negative times negative is positive. Does this give me negative 30x in the middle? Yes, it does. So yes, it is a perfect square, and the right way to write that answer is 5x minus 3 squared. That would be your final answer. Okay, so this is where we are. Step 2. We know our first step is a greatest common factor, which we didn't have one for 25, 30, and 9. So on your second step, we're going to be looking for last night's lesson, difference of squares, and we're also going to be looking for perfect square trinomials. If we don't have either one of those, then we will move on to our product sum, factor by grouping, the long method that we've been doing. So our goal for today is to realize that this is a shortcut. If we can find perfect square, then we have a shortcut. So let's see if these are perfect square trinomials. The square root of 49 is 7, so let's try 7y, same sign, both positive, and the square root of 36 is 6. Now I'm going to factor it the old-fashioned way just to show you. I don't even need to do first and last because I know those are going to be right. So what I have to check on FOIL is not the F, but the O and the I, and I don't need to check the L. So outside is going to be 42y, and inside is going to be 42y. So when we add outside and inside together, we end up with 84y, which is not what we have as our middle term. So the answer is no, this is not a perfect square trinomial. It could be factorable, but that wasn't the question. The question isn't can we factor it, it's to determine if it's a perfect square. So let's try the next one. I know the square root of 9x squared is 3x. I know they're the same sign, both negative. I know the square root of 16 is 4. So what I need to check is a times b times 2. Well, 3 times 4 is 12, and 12 times, or it's going to be negative 12, and negative 12 times 2 is negative 24, not negative 12. So again, it's no. This is not the solution. If you need to set them up the whole way, sure, it's okay to set it up. We know the first term, we know the last term, we're going to check the middle two terms. And when you check the middle two terms, you find out that they did not give us the negative 12y. So I'm going to leave number 3 for you to check on your own. Next, it does say factor completely. So we're no longer looking for is it a perfect square. It just is telling us to factor it. So I take out the greatest common factor, and the greatest common factor between 6 and 96 is 6, and that leaves me with x squared minus 16, which is a difference of squares. So that's x plus 4, x minus 4. And that's factored completely. 16, 8, and 15. They do not have a greatest common factor, so I have to go old school. They're not a difference of squares because there's more than 2 terms. It is not a perfect square trinomial because 15 is not a perfect square. So that means I have to go to product sum. And 16 times 15, it's actually a negative, is negative 240. And the sum, when you subtract, is going to be the sum when you subtract the opposite signs, because one's positive, one's negative, is going to be a positive 8. So I first tried positive 24 and negative 10, which gave me a positive 14, and that's not 8. So then I tried 20 and negative 12, and that one works. I get a positive 8 when I add those. So 16y squared plus 20y minus 12y minus 15. Factor out of 4y plus 5. Factor out of negative 3, 4y plus 5. So factor out 4y plus 5 and 4y minus 3. So there it is, factored out. So don't forget, If it's not a difference of squares, you can always use product sum. So here I'll give you a hint. You're going to take out the greatest common factor, and I'll let you finish and determine if that is a difference of squares. I'd also like for you to try number 4 on your own, number 3 on your own, and number 5. Let me tell you the answer. The answer is going to be a positive 5/3. So see if you can work number 5 and get positive 5/3 as the result of that perfect square trinomial. Okay, square root property. To solve a quadratic equation in the form x squared equals 9, you simply need to take the square root of each side. So solving using the square root property, I don't know where that 2 came from, but here we have b minus 7 squared equals 36. So let's take the square root of both sides. So when you unsquare something that's squared, you have left over b minus 7. And we don't know if it was a positive 6 or a negative 6, so we have to cover ourselves since we have a variable. So positive or negative 6. So when we solve for b, we have to do both 7 plus 6 and 7 minus 6. So my answers are 13 and 1. Those are my possible values of b. I'm going to let you check number 2 on your own. You will have a decimal answer, so round to the nearest tenth for this one, taking the square root of both sides. Then on the next page it tells you that if you use your calculator to check your answer to number 2, we will do more with our calculators in our next chapter, but there's an intersect feature on our graphing calculator. When you set y equals this quadratic x plus 9 squared and you check the intersect feature, you will find out that one of the solutions is negative 6.17, which if you round it to the nearest tenth, it's negative 6.2. And it shows up here at the bottom of your screen. So we'll practice that more in class, and again, stay tuned for next chapter. Let's solve the following 2 solutions. Let's just practice. I'll do one and leave one for you to do. Taking the square root of both sides, this is x minus 4 equals positive or negative 5. So x equals, and it seems like I'm working the numbers that are not decimals, 4 minus 5, so I end up with 9 or negative 1 as our roots. So again, these will be decimal answers. You can round to the nearest tenth, but it's the same math. Let's look at a real world example where we're given a physics problem, and here's the equation where h sub 0 stands for the initial height. Okay, a book falls from a shelf at 60 inches above the floor, so that's our initial height, and h is going to be the height after it is dropped, so when it hits the floor it'll be at 0. So 0 equals negative 16 t squared. We're looking for the time. Use this model to get approximately how long it took the book to reach the floor. So how long did it take to land at 0? And we started at 60. Alright, now that does not look like a difference of squares. Let's get our 16t squared positive, and I could even leave it equal to 0, divide by 16, and how do we unsquare t squared? We're going to need to take the square root of 60 over 16, which is approximately 1.9 seconds. Alright, I will leave number 2 for you to check on your own. And that does it for Chapter 8. I hope that you are working a little bit every day to get better and better at factoring. Alright, have a good one.